Number 39 on page 440 asks us to use a picture to find the height of the flagpole. So we know many things about the flagpole. We know how far away we are standing. We're at point A. We can see the length of the shadow. We know different angles that are made with respect to the flagpole. So what we want to find is side A of the flagpole. So in order to do that, we need first to angle A, and then since it's an obtuse triangle, we won't be able to use the Pythagorean theorem. We'll have to use the law of sines. So we're going to go ahead and find angle A. So the measure of angle A is going to be 180 minus the 28 degrees made at the top of the triangle near the flag itself, minus the angle made with the ground and the flagpole, which is 105 degrees. And so when we subtract those two angles from 180 degrees, we get an angle measure of 47 degrees. And we know it's not going to be ambiguous because we have angle, angle, side. So we can use side C, which is the length of the shadow, and the 28 degree angle, which is angle C, as well as now we have angle A to find the height of the flagpole, which would be side A in our picture. So we are going to use that sine of angle C over side C is going to equal sine of angle A over side A. And the answer to this ratio is going to be our height of our flagpole. So we're going to take sine of 28 degrees over 16 feet, and that's going to equal the sine of 47 degrees divided by length of side A. So rearranging this and solving for A, we get that side A is going to equal 16 feet times the sine of 47 degrees divided by the sine of 28 degrees. And when you put that in your calculator and simplify it, we get a value of 24.93 feet, almost 25 feet tall.